So to review for your quiz, let's go through this review of systems of equations. So what's going to happen is you're going to take the quiz, you'll work out a few problems, and you'll realize that you get some ordered pair solution. Well, of course, the question is, does that ordered pair solution check? So that's basically what 1, 2, and 3 are. This is the last step in solving. You want to make sure it's the right answer, so you go in and you check it. So all I want to know is the given order pair a solution? So let's start with number 1. In my first order pair, let's substitute x equals -2 and y equals -4. So as I've done before, we're just going to substitute in here. So let's look at -2 plus 4. X plus y, -2 plus 4. -2 plus 4 equals 2. Does that match? Yes, it does. Now, that means that it's a solution in that equation. So now let's look into equation B. We have x minus y, -2 minus 4. That equals -6, and this equals -6. So yes, 1, 2 is a solution because it is a solution to both equations. Oh, goodness gracious. To both equations. So basically what I'm saying is both check. Okay. So let's look at number 2. Number 2, let's see what happens when x equals 3 and y equals 1. So when we look into equation A, 3 times 3 plus 1, well, 3 times 3 is 9, 9 plus 1 is 10. Does that equal -8? No. So this one is a no, because 3, 1 is not a solution to, I'm just going to say equation A. Oh, I guess I should label it equation A if I'm going to call it equation A. Okay? So far we have a yes, we have a no. Number 3. Let's look in equation A. I'm going to do this one a little differently. Does y equal 2 times x? Does 2 equal 2 times 1? Does 2 equal 2? Yep, so this one checks. And now for equation B. Does y equal x plus 1? Does y equal 1 plus 1? Well, yes, it does. So it checks there. So yes, 1, 2 is a solution to both equations. And there it is. So that is always your very last step. Once you've done all the algebra, you've substituted, eliminated, graphed, whatever, you got an order pair, you want to check it. So you want to make sure that they're the correct answers, so you always plug it in. Okay, next we get to matching graphs. So here are the 4 systems on the left. We want to match them with the graphs on the right. So let's see what happens here. Let's start over here with these solutions. When I look at this graph, I see that there is no solution here because I have parallel lines. When I look at this graph, I see the solution is 2, 1. When I look at this graph, I see the solution is -1, 4. And when I look at this graph, I see the solution is -1, 4. And I'm sort of glad that this happened, because what happens is, historically, I'll ask my students to graph the systems, but they don't want to graph because they don't remember how, or they're uncomfortable. So they'll use elimination or some other method to find the solution. And then they'll fake a graph. They'll think, well, let me just draw 2 lines and have them meet at a common point. but it doesn't work like that. Your lines actually have to be accurate. So when I look at number 4 in equation A, actually I'm jumping right into equation B. When I see y equals 4, I know that this is a horizontal line. The only horizontal line occurs here. So this must be the graph to number 4, because there are no other equations. But just to double check, my y-intercept is -3. My slope is -7, which is -7 divided by 1. So my y-intercept is -3. I can't go down 7 because there's no room, but I can go up 7 and to the left 1. Up 7 to the left 1. So this is the solution for number 4, or is the correct graph for number 4. All right, so for number 5, my y-intercept is -4. My slope is 5/2. For equation B, my y-intercept is 3. My slope is -1, which is -1 divided by 1. So I need to look where I have a y-intercept of -4. I have a y-intercept of -4 here. My slope is 5/2. So we go up 5 to the right 2. I think this is it, because my y-intercept is 3. My slope is -1 divided by 1. So this must be the graph for problem number 5. Number 6, what do you notice? Same slopes, different y-intercepts. That means these lines are parallel. Okay, that's what they lead to. They lead to parallel lines. Which graph has parallel lines? Number 6. And then I can check it. My slope is -2/3. So my y-intercept is -3, down 2 to the right 3. Here, down 2 to the right 3. And so by default, number 7 must be this graph. But I do want to give a little attention to number 7 because it's in standard form. I love standard form. I know that when I look at equation A, when I cover this up, I find that I've got an x-intercept of 3. And when I cover up the x, I see that I have a y-intercept of 3. So on my x-axis, I plot a point at 3. And on my y-axis, I plot a point at 3. And there's my line. But let's actually work through this one. I'll write these in slope-intercept form. So for equation A, if x plus y equals 3, we'll subtract the x from both sides. And so y equals -x plus 3. That's a y-intercept of oh, my bad. Y-intercept of 3 and a slope of -1. The y-intercept is 3, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Okay? Now for equation B, if I have 8x plus y equals -4, I will subtract the 8x from both sides. I find that y equals -8x plus 4. So my y-intercept is 4. My slope is -8, which I will write as -8 divided by 1. Y-intercept is 4. Oh, dude, what'd you do, Denise? Oh, man. It's actually -4. See that negative? I dropped it because I'm a dummy. So y-intercept is now -4. I can't go down and to the right, so I'm actually going to write this way so I can go up and to the left. Okay, so that's another way to look at it if I've not used process of elimination. Okay, so now I want to look at some word problems. So what's going to happen is today I'm more concerned, I'm concerned with everything. I want to make sure you know how to write a word problem, but I also want to make sure that you can solve it. So That's what we're going to work through today. So let's look at this first one. A test has 20 questions worth 100 points. The test consists of true-false questions worth 3 points each and multiple choice questions worth 11 points each. How many multiple choice questions are on the test? All right, so here's what we want to do. We want to let T equal the number of true-false questions. We want M to equal the number of multiple choice questions. Okay. So the first thing I notice is I've got a number of multiple choice and a number of true false. So when I mix those two up together in whatever combination it is, there have to be 20 questions. So what am I saying? I'm saying when you add the number of true false to the number of multiple choice, you get 20. Okay, so I've taken care of the 20. Now I need to look at the points. All right, so how do the points work here? Well, where else do I see points? Well, I see true false is worth 3 points. I see multiple choice is worth 3 points. Right here. 11 points, my bad. So that's what I'm looking for that equation. So something equals 100 points. Well, how do I break down the points? So here's the question. If I have, let's look at the number of true false. Let's say I have one true false question and I get it right. How many points will I get? I'll get 3 points. If I have four true false questions worth 3 points each, how many points will I earn? 12. 10 true falses, well, that makes 30. How am I getting that number? Well, if I have T true false questions, I'm multiplying by 3. So that means the points I earn from true false equals 3T. Likewise, I'm going to do the same for multiple choice. So one multiple choice gives me 11 points. 2 multiple choices gives me 22 points. 3 multiple choices gives me 33 points. So what about M multiple choices? Well, that'll be 11M. So that's where 11M comes from here. And it's actually good because I'm going to solve this one and I'm going to use elimination. So I think I want to eliminate T. So if I have 3T here, what eliminates 3T? Negative 3T. So let's multiply this by negative 3. When I do that, I'm left with 3T minus 3M equals negative 60. And I'm going to carry this over as is. 3T plus 11M equals 100. So when I add, my T's will eliminate, and I will be left with 8M equals 40. And in order to solve for M, I divide by 8, and I find 5. So I know there are 5 multiple choice questions on the test. Look what it asked me. How many multiple choice questions are on the test? 5 multiple choice questions. Oh, wow, that worked out nicely. Okay, there it is. And then you want to check it. If there are 5 multiple choices, then there are 15 true falses. So let's see what happens there. If I have 5 multiple choice, so 11 times 5 is 55. And then we said we're going to have 15 true false. No, my bad. So let's do 3 times 15. I'll get 45. Well, what happens when you add 55 plus 45? There's 100 points. It was a horrible way to check, but I got the right answer. dude, won't happen again. All right. Number 2, the difference of two numbers is 3. Their sum is 13. What are the two numbers? Well, let's let A equal the first number. Let's let B equal the second number. So the difference. What operation is implied by difference? Subtraction. So I know that A minus B equals 3. Their sum, which means when we add them, we should get 13. So A plus B equals 13. And I would have students, no lie, they would say, oh, it's 5 and 8. Show me how you got it. Mental math. I said, okay, that's fine, tough guy. Then I said, what if the sum was negative 3 and the difference was negative 13? It was a totally different story then. So you've got to be able to come up with a system that would work for any type of number. So I want to solve this one by elimination. I'm going to add these, and I'm left with 2A equals 16. So A equals 8. Well, 8 minus what is 3? 5. So the two numbers are 8 and 5. And this is the easiest check of all. What's 8 minus 5? 3. What's 8 plus 5? 13. So I know that's the right answer. Okay, number 3. The admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people enter the fair and $5,050 is collected. How many children and how many adults attended? Okay, so they're asking me how many children. So C equals the number of children. How many adults attended? So we will let A equal the number of adults that attended. All right, so I look right away and I see dollar signs and decimals. My eye is drawn to that. So maybe I should start with an equation about revenue. So how much money does the fair take in for children? Well, it takes in $1.50 per child, which you told us, Robadier, says that you multiply those two. And we're going to earn money from adults, and we're going to earn $4 per adult. And the money that we earn will be $5,050. The other piece of information I have is right here. There are 2,200 people. So that means that the number of children plus the number of adults, because we put them together, equals 2,200. And I'm going to save this solution for later, because right now I just want to make sure that you can solve that. I'm just feeling lazy, and I'm not feeling decimals right now. Okay, number 4. At an ice cream parlor, ice cream cones cost $1.10 and sundaes cost $2.35. One day, the receipts for a total of 172 cones and sundaes were $294.20. How many cones were sold? All right, so let's let I equal the number of ice cream cones. And let's let S equal the number of sundaes, because they're asking how many, so they want to know a number. And it looks like all they care about are the number of cones. All right, so again, I'll start with the money equation. $1.10, $2.35, $2.94.20. So $1.10 per ice cream cone plus $2.35 per sundae equals $2.94.20. And the receipts for a total of 172 cones. All right, total. What operation is that? Addition. So two numbers are adding up to 172. What are we adding up? That's easy, Robadier. We're adding the number of ice cream cones, called I, to the number of sundaes, called S. And there's my equation for those, my system for those. All right. Lisa goes to the mall one day and buys 4 shirts and 3 pairs of pants for $85.50. She returns the next day and buys 3 shirts and 5 pairs of pants for $115. What is the price of each shirt and each pair of pants? So we want to know the price of a shirt. So we'll call it S. We want to know the price of a pair of pants. Okay. So 4 shirts and 3 pairs of pants are $85.50. So let's put that together. 4 shirts plus 3 pants equals $85.50. And then we see that 3 shirts and 5 pants are $115. Okay? And at the end of the video, when I mean later, I mean like 5 minutes later, I didn't want to get bogged down in all the solutions, and then you totally lose the whole moral of the story here in setting them up. So once I've set them up, I'll go back and solve them. Okay, number 6. Find 2 numbers if one number is 1/2 of the other and their sum is 12. Well, dang. So let's let n equal one number. And I can't use O. Dang, I should have used a different variable. Okay, let's let m equal one number. And let's let n, oh, good grief. Let's let n equal the other number. Okay. One number is half of the other number. So one number, m, so one number is m. You see is means equals. 1/2 of, what does of mean in math? Multiply. What's the other number? N. Boom, look at that. Their sum is 12. Something equals 12. Well, what equals 12? Their sum. Well, what does sum mean? Sum means that we add these. Okay? So that's how I'd set it up. One number is half of the other. The sum of the 2 numbers is 12. Now, if you can figure out 8 and 4, more power to you, because that's what they are. All right. So if you were fine with just setting these up, then feel free to stop the video now. Otherwise, I'm going to solve 3, 4, 5, and 6. So now is later. I told you we would come back and solve these later. Let's go ahead and do it. What I didn't want to do is get so wrapped up in the decimals and in the solution that we lose the whole purpose of this lesson, which was, can you set it up? You know, I don't want to trip up on the solutions that we kind of miss everything else. So let's go through and solve these if we can. So let's look here at number 3. How would you want to solve that? You can use substitution. You can use elimination. I wouldn't recommend graphing because I don't want to graph to 5,000, regardless of the scale that I use. I think what I'm going to do is I'm going to use elimination. And I think I would like to eliminate the C, just because I would rather eliminate the smaller variable. So the top equation, I will leave alone. Actually, I'm going to rewrite everything, if that's okay with y'all. And equation B is C plus A equals 2200. Okay, so again, to eliminate the C, if this is 1.50 C, this needs to be negative 1.50 C. So that tells me that everything down here has to be multiplied by negative 1.50. And when I do that, I'll get negative 1.50 C minus 1.50 A equals, and yeah, I need my calculator here. All right. Negative 1.50 times 2,200 is negative 3,300. The top equation will just come over as it is, and that is 1.50c plus 4.00a equals 5,050. So when we add, we'll eliminate the c. 4 minus 1.5 is 2.5. And then 5,050 minus 3,300 is 1,750. And so now to solve for a, we'll divide both sides by $2.50. And I find that a equals 700. And I got so wrapped up in solving it, I forgot what a equals. But dude, I'm so glad that I defined it. So I know that there are 700 adults. Now I need to find the number of children. Well, equation B tells me that the number of children plus the number of adults is 2,200. So I know that the number of children plus 700 is 2,200. So when we subtract the 700 from both sides, we find that there were 1,500 children. And that's a nice thing about defining them. I can put my answer there right away. And I do want to check this just because after doing all that work, it would really suck for me to get it wrong over some little thing. So let's look at what we have here. 1.50, let me start over. So if we collect $1.50 from every child, there are 1,500 of them, plus $4 from each of the 700 adults, I should get $5,050. Oh, thank goodness. And then when I add, I can do that right here. When we add these, we do get 2,200. So there are 1,500 children. And I wouldn't write this again. If there were only one space, I would say right here, right there. But if they have a space, I should fill it. All right, so there it is. Boy. Okay, I'm going to do the same thing now for problem 4. I'm going to write my equation, and I do believe I'm going to solve this in the same manner. So this was problem 3. So let's look at problem 4 here. I have $1.10 per ice cream plus $2.35 per sundae equals $294.20. I know that the number of ice creams plus the number of sundaes adds up to 172. Okay, so I do believe, again, I would like to eliminate the I because it's smaller. So the top equation is going to stay the same. S's bother me because I'm so worried that I'm going to confuse them for 5s. So you be very careful as well. All right, in order to eliminate $1.10 I need negative $1.10. So everything here in the bottom equation has to be multiplied, by negative 1.10. So I'll get negative 1.10I minus 1.10S equals, okay, so let's take negative 1.10 times 172. We'll get negative 189.20. So now we're going to add so that we eliminate the i's. And when I do that, 2 minus 1 is 1. 25 or 35 minus 10 is 25. So I really have 1.25s. And I'm going to take 294.20 minus 189.20, and I'll get 105. And now in order to solve for S, I'm going to divide by $1.25, and I get 84. S equals 84. What does 84 equal? Oh, 84 is the number of Sundays. So there are 84 Sundays. So which one looks easier to solve for I? Well, I think it's going to be equation B. So when we look into equation B, where I plus S equals 172, S is 84. So I plus 84 equals 172. So when we subtract, I equals 12 minus 4 is 8. 16 minus 8 is 8. So it looks like there were 88 ice cream cones. Well, let's check this. 8 plus 4 is 12. 1 plus 8 is 9. 9 plus 8 is 17. I think that's it, but let me double check with my money because, my money's always got to be right. I don't know about you, but mine does. So we'll take $1.10 times how many ice cream cones? 88 plus $2.35 for our Sundays. Please be $294.20. Yes. Okay, so that's correct, and this one's correct. So now I've done all this work. Did I answer the question? How many cones were sold? 88 cones were sold. All right. Now let's look at number 5. I look at these two equations, and it looks to me like elimination is the way to go. And so when I eliminate these, I believe what I'm going to do is, do you have a preference for what you want to eliminate? Let's see. So 4S plus 3P equals 85.50. 3S plus 5P equals 115. So I noticed that both equations are going to have to change. There's no easy way to turn 4 into 3 or 3 into 4. There's no easy way to turn 3 into 5 or 5 into 3. So now we just have to decide, do we want to eliminate S or do we want to eliminate P? And it looks like we should eliminate S's because then we're messing with 12. If this is 12, this should be negative 12. Otherwise, we'll mess with 15 and we'll just go with 12. So let's take the top equation and multiply it by 3. 12S, let's see, 4 times 3 is 12. 3 times 3 is 9. And this equals 85.50 times 3, 256.50. Pardon my small writing, but that's the only way to fit this in. Should have used just a regular sheet. So this one, let's multiply by negative 4. That way we'll get a negative 12S when we distribute. Minus 20P equals negative, let's see, negative 4 times 115 is negative 460. And I'll throw in some zeros if you need them for the dollars. Okay, so when we add, we will eliminate the S's. We're left with negative 11P equals, let's take 256.50 plus negative 460. I mean, the way I was going to do it is the same, but let's just keep everything accurate or consistent. Negative $203.50. Now let's divide by negative 11. Please give me a nice, pretty answer. When I divide by 11, I get negative 18.5. And y'all, this is money. It doesn't go 3 decimal places. It doesn't go 2 decimal places. It goes 1 decimal place. So when I fill in the price of a pair of pants, it's not going to be 18. It's not going to be 18.5. like you would find on the Bonefish Grill menu. No, you need the 0 in to show 2 decimal places, and you need the dollar sign. Now we need to find the price of a shirt. So which one do we want to substitute into? I would substitute into equation A because the numbers are smaller. So if 4S plus 3P equals 85.50, 4S plus 3 times 1850 equals 85.50. And again, I'm going to multiply. 3 times 1850, we'll get 55.50. See why I saved this for later? There's so much. So 4S equals 30. And then when we divide by 4, S is 7.5. But remember, we're dealing with money. So we need a dollar symbol and we need 2 decimal places. Again, money is 2 decimal places. And look at the dollar symbol. It is in front of the number. It's not behind the number. That's what lazy people do. And now I really do want to check this sincerely because there are so many places I can make mistakes. Anytime I deal with decimals, I'm worried about making a mistake. So we're going to take 4 times a shirt, which is $7.50, plus 3 times a pair of pants, which is $18.50. We should get $85.50. Oh, yes, we did. So now let's take 3 times the price of a shirt. I'll use parentheses this time. Plus 5 times the cost of a pair of pants. And I should get $115. And I do. So guess what? We're going to say a shirt costs $7.50. Pants cost $18.50. Answer the question. Answer the question. And the last one, I have the system M equals 1 half N. And I have M plus N equals 12. This looks like substitution. I know that's not what you want to hear, but that's how it is. So when I look at this with substitution, I see 1 half N. I see M is isolated. So I look at 1 half N, and that's going to substitute there. So it looks like I'm taking the information from equation A, and I'm going to substitute it into equation B. So instead of M plus N, I'm going to have 1 half N plus N equals 12. Okay? So 1 half plus 1, remember, is 1 and 1 half. 1 and 1 half is really 3 halves. How do you get rid of 3 halves? I'm so glad you asked. You multiply by 2/3. And when I do that, N is 2 times 12 is 24. 24 divided by 3 is 8. So it looks like one number is 8. And their sum is 12. So if one number is 8, the other number has to be 4. So let's mental math this one. Is 4 1 half of 8? Yeah. And does 4 plus 8 equal 12? Yeah. So they both check. So find 2 numbers. The 2 numbers are 4 and 8. Okay, so turn your word problems into systems. Use either elimination or substitution to find it. Answer the question. or you can always fall back on graphing. The key here is to remember that the ordered pair solution is where they intersect. Remember, no matter what else happens, you can always plug the ordered pair back into the equation to make sure that it checks. That's everything you need to know.